We're going to start working on a new handout called Average Rate of Change of Functions. And the material in this handout is related to linear functions. Linear functions have a constant rate of change, and that constant rate of change is the slope of the linear function. Other kinds of functions don't have a constant rate of change, but we can talk about something called average rate of change. And average rate of change is related to the idea of slope, but there's a little bit more to it. So let's start talking about this example. I want to start with an example before I give you any kind of general formula, because I think this example helps bring things to life a little bit. So here I call it exercise 1. Cynthia is driving from Los Angeles to Stockton on I-5. Suppose that her distance from Los Angeles after X hours is given by the following function. F of x equals x to the fourth minus 8x cubed plus 16x squared plus 70x, where the units of f of x are miles. Cynthia arrives in Stockton after 4.5 hours. Now, this is a pretty complicated looking function. It's definitely not a linear function. The input units are hours. The output units are miles traveled. And I want to go ahead and figure out a bunch of values for this function. And I have a table here that we're going to fill in. Now, I wouldn't ask you to do all this by yourselves, so don't panic about it. It's very tedious to calculate all these values. But I just want you to realize that we can just plug in. F of 0 is 0. It's not too hard to see that, right? Because I get 0 to the fourth minus 8, 0 to the cube plus 16, 0 squared plus 70 times 0 is 0. So, and that just means after 0 hours, Cynthia hasn't gone anywhere yet. And I am just going to do f of 1 by hand here, so you see what's 1 to the fourth minus 8 times 1 cubed plus 16 times 1 squared plus 70 times 1. That's going to be 1 minus 8 plus 16 plus 70 is, I think, 79 when I work it out. So there's 79. Now, I did all the rest of these values in the table ahead of time. And again, don't worry, I would never ask you to do this because it does get a little bit tedious. It gets real tedious. And I also rounded off some values to the nearest mile here. So 0, 38, 79. At 1.5, I got 119. At 2, 156. 2.5, 189. 3, after 3 hours, 219. 248 for 3.5. For 4, 280. And at 4.5 hours, I got 320. Okay. So if you want to think in terms of a map, I'm going to kind of draw a dot. Here's LA. Here's Stockton, north of LA. And Cynthia's just driving along I-5, right? And I think this total distance is 320 miles. And it takes Cynthia 4.5 hours, 4.5 hours to travel that distance. So now we're going to answer some questions about this data. And the first question is, what's the relevant domain for the function f? And it's just values of x in the interval from 0 to 4.5. It doesn't make sense to go beyond that. Certainly negative numbers make no sense. And at 4.5 hours, Cynthia arrives in Stockton. So at that point, she stops, stops driving. All right, now I'm going to start writing some of these on a separate sheet of paper. So for instance, A, the domain is x in the interval 0 to 4.5. For part B, we're being asked how far has Cynthia traveled after 1 hour. And there's really nothing to figure out here. I just want to make sure you realize that's f of 1, which is 79 miles. So in the first hour, she drove 71 miles. And then I say after 2 hours is f of 2, which we can just copy from our table, is 156 miles. After 3 hours, what's 3? 209, f of 3 is 219 miles, copied off the table. After 4 hours is f of 4, which is 280 miles. And after 4.5 hours, she's gone 320 miles. Okay, so just copying down some information, making sure we see what that table of values actually represents here. Sorry, I'm jumping around on a page here. Now, here's what we're interested in. We are interested in how fast Cynthia drives, and we will analyze her, what's called her average speed over several portions of her trip. Now, average speed, you're familiar with speedometer, or speed on a car, miles per hour. When we write miles per hour as units, the per can be thought of as division. So we're going to take miles traveled divided by hours, or over hours. We can write that as a fraction. So in part C, we want to compute the average speed from x equals 1 to x equals 3 hours. Cynthia's average speed from x equals 1 to x equals 3 hours. Well, the average speed is going to be miles traveled over how many hours have gone by. We can get the miles traveled by taking the difference of the two distance readings we have. So after 3 hours, she traveled 219 miles. Now, that's the total distance she traveled over 3 hours. From the first hour to the third, we want to subtract off f of 1. We want to subtract those first 79 miles. So I'm taking 219 minus 79. This gives me the distance traveled from hour 1 to hour 3. And the time that went by is, now it's 2 hours, but I'm just going to emphasize that by writing 3 minus 1 down below. And that's actually 140 over 2, or 70 miles per hour. I'll write mph for miles per hour. So that average speed from x equals 1 to x equals 3 hours is 70 miles per hour on average for those 2 hours. D is average speed from 2 to 4. So we're going to do the same thing. All right, average speed from x equals 2 to x equals 4 hours. And it's the same kind of calculation again. Miles traveled divided by hours. I'll just write this out one more time. So it's the same formula, but the miles traveled from 2 to 4 hours. Now 2 hours is going by again, but we're going to take her distance after 4 hours, which I have up above is 280 miles, minus her distance after 2 hours, 156. So that difference will give us the distance she traveled from the 2-hour mark to the 4-hour mark. And then we're going to subtract by 4 minus 2, or 2 hours below. And let's see, 280 minus 156 is, I think, 124 over 2, or 62 miles per hour. Okay, so from 1 to 3 hours, she was averaging 70 miles per hour. From 2 to 4 hours, she was going slower, right? 62 miles per hour. And notice those intervals of time overlap. Okay. E is average speed during the first hour. Average speed during the first hour. Well, we could just say that's the distance traveled during the first hour divided by 1 hour. Now she went 79 miles in that first hour. I'm just going to write 79 divided by 1, which is 79 miles per hour. She was going pretty fast, right, for part E. Part F. If you want, by the way, you can think of this as, I'll write this in front. I could, to make it look like the others, it's like 79 minus 0, or 1 minus 0, because we're starting at that time 0, distance 0 point for the first hour. And then F, what's her average speed? X equals 3 to 3.5 hours. So her average speed, it's just same calculation again. It's going to be distance traveled. Now I don't have it written up above. I got to go back to the chart from the problem. After 3.5 hours, she had gone 248 miles. Minus, after 3 hours, 219. Over 3.5 minus 3. Okay, get it back over here. So for part F, we got 248 minus 219 is 29 over 0.5. So just notice we're only looking at a half-hour time period, and yet when we calculate, she's only traveled 29 miles, but 29 divided by 0.5 hours is going to be 58 miles per hour. So she didn't actually travel a whole hour at 58 miles per hour. So this idea of average speed, if you apply it to a shorter time period, it's kind of like if you continued for a whole hour, this is how far you would have gone at that rate, right? And G, we want X equals 4 to 4.5 hours. So we're just doing this over and over again. 4 to 4.5 hours is going to be, again, her distance after 4.5 was 320 miles, minus her distance traveled after 4 hours was 280 over 4.5 minus 4. And so she traveled 40 miles during that half hour for half an hour. And that comes out to 80 miles per hour when you divide it out. So she was putting the pedal to the metal for that. I think she was getting a little behind time or something and was in a hurry to get there near the end. So we won't talk about speeding here. And H, what was the average speed for the entire trip? The average speed for the entire trip was going to be her distance at the end minus her distance at the beginning, which when she hadn't gone anywhere, divided by 4.5 hours at the end, minus 0 hours at the beginning. 4.5 hours have gone by. 320 divided by 4.5. This I rounded off a little bit. Just it's about 71 miles per hour. So for the whole trip, she was averaging about 71 miles per hour. Now, sometimes she was going faster, sometimes she was going slower, but on average, she was going 71 miles per hour. So there are all these different readings of average speed that can be applied to this problem. That's the observation I want you to make. This is not a constant rate of change like slope of a line where it would come out the same over and over again. If her trip was represented by a linear function, all of these average rates would have been the same. And just one last comment I want to make about some of these. I just want to talk about the look of some of these calculations that we did. 219 minus 79 over 3 minus 1. We could have described that in function notation as f of 3 minus f of 1 over 3 minus 1. I want to pull another one out here. 248 minus 219 over 3.5 minus 3. That's like f of 3.5 minus f of 3 over 3.5 minus 3. So each one of these average rates can be described as a difference of function values divided by the corresponding difference of input values. So and I think that's it. And we'll turn this into a more general formula